Hey everyone, in this video we are going to be measuring the standard deviation of a sample set. And we're going to be doing this calculation by hand, which I would not recommend doing for any large sets, but for my classes we practice calculating standard deviation for small sample sets. We're going to go through this step by step. Here we go. Step 1. We are going to solve the mean. Solve x bar. This is the mean of our sample, and if you're up to standard deviation, you should have some practice solving means by now, which means we just add them all together, 12 plus 12 plus 14, and you can see that although we can do this by hand, it will be quite a bit of work if you had to do this for a really large set of numbers. So that equals 15. Once we have our mean, so the average of this list, that's 15, our step 2, we are actually going to do something so that for each number in our list, for each number in our list, so that's this original list right up here, subtract the mean. And what this is going to do is tell you how high above the mean you are, or how much low below the mean you are. And we end up with something like this. 12 subtract 15 is negative 3. That's because 12 is 3 below the mean. And we can repeat this. We have a 12 again. That's minus 3. 14 subtract the mean, which is 15, is minus 1. But now they're actually above the mean. So 17 subtract 15 is 2, and that 18 is 3 above. And if you end up with a whole bunch of decimals here, that's okay. Don't worry about it. It's still all going to work. It turns out, even if you forget whether you take this number and subtract the mean, or do the mean subtract this number, we're going to get the same answer, because in step 3, we are going to square each number. Square each number. And you're going to end up with a list that looks like this. Negative 3 squared is 9. Negative 3 squared is 9. And what this does is really magnifies differences. So if you were really close, that number will stay small. But if you're really far away from the mean, once that squares it, it's really going to highlight that and make this a bigger number. So I just went ahead and cleaned that up. I kept our new list up at the top so we can still see it, and we're going to move on to step 4. For step 4, we are going to get a new sum. Get a new sum. That means we're going to add up this brand new list of numbers. So it's going to be 9 plus 9 plus 1 plus 4 plus 4 plus 9, and that's going to equal 36. It's really step 5 that we need to keep an eye out, because step 5 is the one and only difference between the standard deviation of a sample set and the standard deviation of a population. So the difference between measuring 6 people and the differences between measuring 600 or 6,000 people. Because for a sample set, this means we've taken a small sample of the population and we want to account for errors. Divide this number by n minus 1. So usually you would just find a new average and you would divide by n. However, if your sample size is quite small, in this case we only have 6, and in class I often use about the number 30, but it needs to be normally distributed. As that number gets really, really big, the difference between n and n minus 1 becomes negligible anyway, but in this case, my n is 6. 1, 2, 3, 4, 5, 6. This n minus 1 is going to equal 5, which means we do 36 divided by 5 equals 7.2. We do this for small sample sets to account for the fact that 1 or 2 numbers might seriously mess up our standard deviation. So this is a correction. You do not need to do this for large data sets, but you need to do it for small data sets. Our final step, step 6, you are just going to square root, and that's going to bring us to the end. If you do the square root of the 7.2, that's going to equal 2.68, which is our sample standard deviation. And that's why sometimes you'll see standard deviation when we're writing out our standard deviation. You sometimes see it written as a symbol S, or you sometimes see it written as that little lowercase sigma. When we're using that standard deviation S symbol, that means it is a sample set standard deviation. And if it's a sample set standard deviation, that means really small groups. Be thinking below 30. Below 30 in your sample, you should be dividing by n-1 in step 5 instead of just n, which you would do for a larger set. I hope that this was helpful. Good luck with your practicing, and if you have any questions at all, please feel free to leave them in the comments below.